Good morning, everyone. My name is Rajkumar Gupta, and I am a technical solutions engineer at Google, specializing in data flow and PubSub products. In my today's talk, I plan to go over some common user issues and techniques to troubleshoot data flow ML pipelines. Since I work in data flow primarily, I plan to use data flow examples, but the same can be applied to any runner supported by Beam. From the agenda standpoint, I plan to cover a quick overview of Dataflow ML and RunInference, followed by some core RunInference related issues in the category of utilization and stuckness, followed by some non-RunInference related issues. So Dataflow ML provides an infrastructure to the users to run inferences on the trained model using the RunInference transform. RunInference transform supports local and remote inference modes using CPUs, GPUs of user's choice. Dataflow ML supports out-of-the-box model handlers like PyTorch and TensorFlow, and also custom model handlers. Dataflow ML also supports LLM integration and MLOps setup using TFX and QF. In addition to this, the core capability of the Beam framework in the form of different sources and targets is also available. Out of this, most of the user issues are seen around the model serving part. Using this diagram, we can see that in any AI/ML pipeline, the data ingestion and the model training part are typically done outside of the pipeline. The rest of the steps can be done in the single pipeline, including the RunInference transform. RunInference transform is typically the way of taking batch or the streaming data and generating inference on top of it. And RunInference is Beam's way of serving the models and the recommended way as well. In the bottom right code sample, you can see the PyTorch trained model is used for image classification, and the out-of-the-box PyTorch model handler is used for its loading and configuration. Model handler is basically way of telling data flow how to load the model and run inference against it. Talking about the run inference lifecycle, whenever users run inference, typically three things and at least two and up to five things happen all the time. Load model loads one or more copies of the model and keep it ready for the inference. Run inference will take batch data and generate inference using the model loaded during the setup time. Batch element is used for efficiency, and it is common to all ML pipelines, not specific to Beam or Dataflow. Batching is done for efficiency and can be turned off by the users, but is generally not done. With batch, with preprocess and with post-process are decorative functions which can be added before and after the RunInference transform. From a troubleshooting standpoint, these can be disregarded unless specific errors are seen around it. Most of the times, the issues are related to load model, batch elements, or running. After going through the Dataflow ML and RunInference overview, let's look at some core RunInference related issues. Starting off with the small batch sizes. Having a minimum batch size of 1 is fine. Users should pay attention to the mean or average batch size. Sometimes users have issues reported around observing average batch size of 1, even or 2, even if they have configured minimum batch size of 100. The root cause of this is almost always the same and is around how batching is done in streaming pipeline, where small bundles are created to keep the latency low. Users can tweak this by using the parameter max batch duration seconds, which essentially turns into stateful processing and waits for the duration mentioned to group elements across the batches before emitting them. This is not done by default because of two reasons. One, users will have to be able to store the state, and it introduces a reshuffle step which increases which if there are large elements in the pipeline will result in a non-efficient processing. There is not a great in between here, and users can use this parameter and they will get large batch sizes, but it may or may not result in higher utilization. Moving on to next category is around not getting sufficient utilization out of the GPU. And from the data flow metrics below, you can see that there are periods when the GPU utilization is not up to the mark. And it is a cause of concern to the users because of the GPU costs. The first root cause of this could be around the source itself is not pumping in enough data. And the way to troubleshoot that would be to add a reshuffle step before the run inference step and then observe the metrics. The second root cause could be that there are not enough models loaded to feed to the GPU itself. And to understand this better, let's look at how memory sharing is done in RunInference and to understand an ideal topology of a user pipeline. There are three ways in which RunInference shares memory. The first mode and the default mode is loading one model per process because there is one data flow worker per process. RunInference will ensure that the model is shared across all the threads in a given process. And this is done because models are generally memory intensive. And if we don't do that, then it will result in a lot of noise. The second option is to not load one model per process and instead use a single model manager process. The way to configure this is to use large model as true or share model across processes returns true from the custom model handler code. The benefit of using option 2 over option 1 is that it will result in fewer number of wounds, but at the same time, option 2 will result in much low throughput compared to option 1. Even after using option 2, if there are wounds, then using larger machine size is recommended. The third option is to use and specify the number of model copies to be loaded, and that many number of processes will be started, and each model will sit in its own process. This is a good in-between option, and it is available from Beam HDK version 256.on. Linking it back to the utilization, if there are fewer copies of model loaded or large model is set as true, then try and load more number of models, and that should help improve the utilization. Drilling down further into the OOMs, LLM typically use large amount of memory, even the smallest LLMs. The default model of loading one model per process can result in lot of OOMs. Increasing the machine type also increases the number of processes. Hence, try and load fewer copies of the model or share model across the processes or increase the machine type or the accelerator type. The table below highlights typical accelerator type which are recommended for the typical suggested workloads. And each accelerator type generally has the associated machine type which goes well with them and can be used. Lastly, try and decrease the batch size because larger batch size, for example, if there is an image classification pipeline and that bundles a lot of images together to the run inference step, then large batch sizes can result in a lot of noise. Moving on to the next category is where the symptoms are either high backlog is observed in the pipeline or the throughput is low. Check the worker logs to see if there are any OOMs or long-running user operations related warnings around the run inference step. If there are no long-running operations or OOMs seen around the run inference step, then that indicates some kind of issues with the source IO, and that should be investigated. If there are OOMs or long-running operations around the run inference step, then it indicates some kind of issue with the user code or the custom model handler code. And the way to troubleshoot is to use large model as true to load a single model. 90% of the time, the error goes away, which indicates some kind of locking issues with the GPU. After going through the different run inference related issues, coming to the non-run inference related errors, common issues could be around the job is not starting or the job is starting but the workers are taking long time to start up. Watch out in the worker startup logs closely for any errors or warnings which are related to these kind of issues. The best practices and the troubleshooting techniques to call out in this would be using the latest version of the Beam and ML related pipelines libraries as much as possible. Rebuild or use custom container images to avoid installation related slowdown, and don't use latest image tag because that can conflict with the non-production related artifacts. So use specific image tags wherever possible, and also check the container image if it is corrupt for any particular reason. So even after trying the different things discussed so far, and if the issue still persists, then the general recommendation is to try and limit the number of variables by using reshuffle before or after the inference step. From rule perspective, there could be an issue with the model itself. It can be inefficient. So that can be checked as well. In addition to using a higher machine type or sharing a single model, refer to the Dataflow ML docs as well for troubleshooting guidelines, or reach out to the support channel or the Beam community as well for assistance. That concludes my presentation. Thank you very much.